So today we're going to talk about properties of logs. We're going to build on what we talked about yesterday. We're going to learn 3 specific properties. The first one is called the product property. What the product property says is that log base b of x times y is equal to log base b of x plus log base b of y. Okay? So let's look at a little example of this. Log base 2 of 3x. That can be expanded into log base 2 of 3 plus log base 2 of x. The cool thing about these properties is that they stem from our exponent property, so they're easier to remember if you'll connect them that way. So if you'll think about when we multiply the same bases with different exponents, what do we do with our exponents?
You add them.
You add them. So this is x, 7 plus 2 is x to the 9. So multiplication and addition go together based on our exponent properties. Okay? Let's think about our quotient property. The quotient property says that log base b of x over y is equal to log base b of x minus log base b of y. So we're connecting division and subtraction, which has also happened in our exponent rules as well. So as an example, if we had log base 3 of 4x, or sorry, it's not a quotient, log base 3 of 4 over x, that is log base 3 of 4 minus log base 3 of x. Reese?
When you write a fraction for the a value, does that have to be in parentheses?
You'll see it in parentheses most often, so you should go ahead and do it. Blake?
Does your fraction have to be positive because it's like your base? Or not your base, it's your value? Never mind.
You sure?
Well, like, didn't you say like you couldn't have like negative or
Quiet, please. Your base is always greater than 0, but not equal to 1.
Is x over y your base?
No, 3 is your base.
Okay.
Or sorry, in this case, b is your base. Okay? Yeah.
How come? Okay, so it's it is log b x over y, and then when we did the example, it's log 3 4 over x. Why is x in 1?
These are just dummy variables. And it's just you take the log of the numerator minus the log of the denominator.
Oh, I got you.
Okay? All right, so let's think about this in terms of exponents. If we had x to the 7th over x squared, what do we do with those? We subtract them. Okay, so division and subtraction have been going together. Okay, the last property we're going to talk about today is the power property. Log base b of x to the r power is equal to r times log base b of x. So if we have log base 5 of x to the 7th power, that's based on our property that power of 7 becomes a coefficient in front of our log. So this is 7 times log base 5 of x. Let me show you why this one works. I think it's pretty cool. If we had log base 3 of x squared, would you agree that I can rewrite x squared as x times x? Yeah? And then based on our product property, can I split these? Yeah. I would have log base 3 of x plus log base 3 of x. So I have two of the exact same things, right? So that's 2 log base 3 of x. That's why that works. No matter what your power is here, 3, 4, 5, you can just keep expanding them, and then you're going to have all the same things, so it becomes your coefficient. Jason?
So like, what was your answer? 7 log 5x.
7 times log base 5 of x is the simplified, is another way of writing log base 5 of x to the 7th.
Okay, so you can kind of simplify it.
So what these properties are going to help us do are simplify different logs. Sometimes you'll be asked to expand. Sometimes you'll be asked to condense. And other times just simplify. So you're going to see based on our examples that are coming up. All right? So let's start by expressing these as a single log and then simplifying if possible. So log base 3 of 27 minus log base 3 of 9. So which property are we going to use here? The quotient property. So I can write this as log base 3 of 27 over 9. What is 27 over 9? 3. So this is log base 3 of 3. And we know from yesterday, what is log base 3 of 3? 1. Okay? Look at number 2. 5 times log of 2. What can I do with that 5? Yeah, use your power property and turn it into an exponent. So I can write this as log of 2 to the 5th. And what is 2 to the 5th? So I can write this as log of 32. Can we simplify that any further? Do we know a power we can raise 10 to get 32? No, so we just leave it right there. All right, go ahead and look at number 3. Log base 1/3 of x plus log of base 1/3 of 1/9. I'm going to condense this into a single log. So what rule are we going to, or what property are we going to use? Product property. So we're going to multiply our arguments. So this is going to be log base 1/3 of x times 1/9. I can write as x over 9. You could also write it as 1/9 x. That's fine as well.
Wait, where's the x over 9?
X times 1/9 would give us x over 9. Okay?
Is there any way to simplify that?
Not keeping it as a single log. No.
Like, but you could use the quotient property of that, and you might just simply limit it.
Yeah, but that's not what your instructions tell you to do. All right, number 4. Log base 5 of 2 minus 2 times log base 5 of y. So the first thing we're going to do is deal with that 2. That's our coefficient. We're going to move it to become our exponent. So this is log base 5 of 2 minus log base 5 of what? Y squared. Right? And then what rule can we use? Quotient rule. And what would we have? Log base 5 of 2 over y squared. Alrighty, let's look at number 5. Listen to what each of these variables represent so you don't get confused. 7 times log base b of r plus log base b of s, not 5, but s, minus log base b of x. So the first thing we want to deal with is this 7. How could I rewrite this first log? Log base b of r to the 7th plus log base b of s minus log base b of x. Okay? Then when you've got more than one log, you're going to simplify or condense from left to right. Okay? You're going to go from left to right. So we've got log base b of r to the 7th plus log base b of s. So what are we going to do with s and r to the 7th? Multiply them. This is log base b of r to the 7th s minus log base b of x. Okay, now what would we do?
Divided by x.
Yep, use our quotient rule. So this would be log base b of r to the 7th s over x. Questions on that one? All right. Let's practice expanding a couple logs. Going the other way. So we've got log base 10 of 7x. Is that 10 necessary there? No. Nope. All right, how could I write this? Okay. Neither of those can be simplified, so that's our expansion. You don't have to. You can just write log. Base 10 is implied. All right. Number 7, log base 2 of 2x y squared. All right. So let's see. What are we going to have?
Base 2 to x plus
Let's break it up even more. Log base 2 of 2 plus
log base 2 of x plus log base 2 of y.
2 log.
Okay.
Or is it 2?
We'll get there.
Would it also be like log base 2 of 2?
Yeah, but you would have to keep going. All right, what is log base 2 of 2? 1. Can we simplify log base 2 of x? No, so we're going to leave that as log base 2 of x. Plus, how can I write this?
2 log base 2 of y.
Why couldn't you
When you expand it, you need to get each argument to be a single term. This, from this part to this part, uses the power property. So we have an argument raised to a power, so we can move that power into the front as a coefficient. Okay, please try number 8 on your own. Log base 7 of x cubed over y to the 4th. All right, check in with someone sitting next to you.
You get 3 times log base 7 x minus 4 times log base 7. Why did you get that?
All right, what do we get?
3 times log base 7 to the x
Of x
of x minus 4 times log base 7 to the y.
of y. We good on that one?
Yes.
Okay. So we're going to combine what we did yesterday and today now and simplify some logs. Okay? Your goal when simplifying is to get it as simple as possible, meaning get values where you can get values, okay? And leave basic logs where you have to. Now, a couple things to know when you're simplifying logs. Sometimes you're going to go down a path, you're going to try a process, and you're going to kind of get stuck. It's not going to work. So you got to be willing just to turn around and try again. Okay, kind of like with factoring. When you'd start trying one of the processes but they wouldn't work, so you had to go try something else. Okay? Some of these can be frustrating because you think they're always supposed to get down to like 2 or 7. But you're not always going to get down to a single value. Sometimes you're going to have an expression for your answer that has both a single value and a log in it or something like that. You got to be okay with that. Okay? All right, so look at number 9, log base 4 of 4x. Now, based on what we did yesterday, you might be inclined to write this as an exponential. Okay? So don't write this down, but if I tried 4 to the y equals 4x, if I just kind of put a dummy variable over here, can I solve that? No. So writing this as an exponential doesn't really help us. What did we learn today that might help us? Yeah, the product property. So I could write this as log base 4 of 4 plus log base 4 of x. Can I simplify log base 4 of 4?
Yes.
Yeah, what's that?
1.
All right, so 1 plus log base 4 of x. That's all we can do on this one. All right, look at number 10, log base 6 of 1 over 36. We're going to work this 2 different ways. Okay? Let's use our quotient rule first. Using the quotient rule, how could I rewrite this?
Log base 6.
Log base 6 of 1 minus log base 6 of 36. All right, what is log base 6 of 1?
0.
0, because anytime your argument is 1, your log is 0. Minus, what is log base 6 of 36?
2.
2. Because 6 to what power gives me 36? Well, 6 squared gives me 36. And 0 minus 2 is negative 2. Okay? I'm going to rewrite this over here, and we're going to try it a different way. How would we rewrite this as an exponential? Yeah, that? 6 to what power equals 1 over 36? So think about it. We've got to make it flip. So what causes it to flip? Negative. And then we need to do what to 6? Square. So this is -2. Doesn't matter at all which of those methods you go with. Just whichever one makes more sense to you. All right, look at number 11. 2 raised to the 3 times log base 2 of 3 power. Hopefully, this kind of triggers your memory of a rule we learned yesterday. Remember that we learned the rule b raised to the log base b of a power. What does that simplify to? A. Okay? That was our rule that we learned yesterday. So looking at that problem, 2 to the 3 times log base 2 of 3 power, notice that we're really close to that rule. We're just not quite there. Yeah, we need to move this 3. How can we move this 3? Yeah, move it to a power. So this becomes 2 to the log base 2 of 3 cubed. What is 3 cubed? So this is 2 to log base 2 of 27, which means this simplifies into what?
27.
27. Okay? Please try number 12. There's a couple different options for how to approach this, so on your own, please try number 12. Log of 1,000 minus log of 10. Right? Hopefully you worked it one of these two ways. You could have simplified each individual log. Log of 1,000 is 3. How do I know that? Good, because 10 cubed is 3. And then log of 10 is 1. So 3 minus 1 is 2. Or you could have used your quotient property. 1,000 over 10 is 100, and log of 100 is 2.
You can like actually subtract 5. It's like
What do you mean?
1,000 minus 10. That's not 100. Never mind.
Nope, can't do that.
I did that in my head and it worked.
All right, 3 times log base 6 of 2 plus 3 times log base 6 of 3. So our first task is going to be to move those coefficients so that we can simplify. So I'm going to take each of my coefficients and move them to become powers. So this is log base 6 of 2 cubed plus log base 6 of 3 cubed. What is 2 cubed? So this is log base 6 of 8 plus log base 6 of 27. Okay, then what would we do?
Log base 6 of 27.
Okay, and I will go ahead and tell you that 8 times 27 is 216, which is 6 cubed. So how does that help us? Yeah, log base 6 of 216 is 3. That would be a multiplication that you would probably have a calculator for. But it would not be the end of the world if you didn't. Just go off to the side, write it out. You would survive. You would. All right. So now we're going to estimate a little bit. And I'm going to go ahead and tell you, I'm going to give you 2 approximations. I'm going to tell you that the log of 2 is approximately 0.301. Okay, it's not exactly 0.301, it's an irrational decimal. No, you don't need to memorize this. It would be given to you. Log base 10 of 2 is approximately 0.301. Log of 3 is approximately 0.477. All right, and we know log of 1 is what? 0. And log of 10 is 1. So we're going to use these 4 values to help us approximate or estimate these logs. So what I mean by estimate is you've got to get it down to a decimal approximation. Okay? So look at number 14. Log base 10 of 6. Using the information we know, how could we approach this?
You do log base 2 times log, or log, like multiply the 2 together.
Okay, so 6 is 2 times 3, correct? 6 is 2 times 3. So couldn't I write that as log of 2 plus log of 3? And do we know log of 2? What is it? Approximately 0.301 plus 0.477. If you need to rewrite this on top of each other, that's totally fine. We get 0.778. And yes, before you ask me, I would expect you to be able to add those values without a calculator. All right, look at number 15. Log base 10 of 30. Think of the information we have. Ideas? Good. 30 is 3 and 10, 3 times 10. Now, would you agree 30 is also 6 times 5? And 15 times 2? But do we have the approximations to help us with those? No. So we have to strategically pick how we want to break it up. Okay? So I know that log of 3 plus log of 10 will give us 30. Log of 3 is 0.477. Log of 10 is 1. So this would be 1.477. All right. Look at log of 2/3. What are we going to have to do there? Log of 2 minus log of 3, which is 0.301 minus 0.477. Okay, reach back in the vault to your elementary school years. Put the big number on top. Subtract the smaller number. We know our answer is going to be what? Negative. 7 minus 1 is 6. 7, 1. Bring down your decimal. 0.176. Yep.
I thought that logs like had a domain restriction, like at the vertical axis. So it's like they can't be negative.
A parent function would not be negative. Well, no, this is not a domain value. This is a range value.
Oh, okay.
It's a what value?
This is a y value essentially. Okay. All right, look at 17. Log base 10 of 0.006. How do I say 0.006? 6,000, right? How could I write that as a fraction? Yeah, would you agree that's 6 over 1,000? Everyone okay with that? All right, so how could I split that? Log of 6 minus log of 1,000. We already found log of 6. What is it? 0.778. And what is log of 1,000? 3. 10 cubed is 1,000. All right, so you've got 3.000 minus 0.778. You gotta do some canceling. Ten minus 8 is 2. 9 minus 7, 2. 9 minus 7, 2.2. So this is negative 2.222. Okay? All right. When I give you your homework, you need to make a couple notes about it. The first is that on numbers 1 through 12, you are allowed to only do the odds. Save the evens for review later this week. Okay? You may cross off number 14 because we already did it. And your instructions on numbers 19 and 20, you need to take off the first part and just leave simplify if possible. Okay?